Now, performing row operations on a matrix. Now that we can write systems of equations in augmented matrix form, we will examine the various row operations that can be performed on a matrix, such as addition, multiplication by a constant, and interchanging rows. Performing row operations on a matrix is the method we use for solving a systems of equations. In order to solve the systems of equations, we want to convert the matrix to row echelon form, in which there are ones down the main diagonal from the upper left corner to the lower right corner, and zeros in every position below the main diagonal. Now we use row operations corresponding to equation operations to obtain a new matrix that is row equivalent in a simpler form. So here are the guidelines to obtaining row echelon form. Step number 1, in any non-zero row, the first non-zero number is a 1, meaning in the upper left-hand corner. It is called a leading 1. Number 2, any all zero rows are placed at the bottom on the matrix. Number 3, any leading 1 is below and to the right of a previous leading 1. And number 4, any column containing a leading 1 has zeros in all other positions in the column. Now, to solve a systems of equations, we can perform the following row operations to convert the coefficient matrix to row echelon form and do back substitution to find the solution. Number 1, if you want to interchange the rows, this is the notation for it. You have this row and then that notation. If you're going to multiply a row by a constant, it's going to be c times whatever that row is. And number 3, if you're going to add the product of a row multiplied by a constant to another row, then you would have a row plus whatever the constant is times that row. Now, each of the row operations correspond to the operations we have already learned to solve systems of equations in 3 variables. With these operations, there are some key moves that will quickly achieve the goal of writing a matrix in row echelon form. To obtain a matrix in row echelon form for finding solutions, we use Gaussian elimination, a method that uses row operations to obtain a 1 as the first entry so that the row 1 can be used to convert the remaining rows.